DesignCon as a show appears to be growing. It appears to be getting more busy, which is a good thing for the organizers. I think it's an important show. It's very much about signal integrity and about engineering that signal path between chips. And that's really important, and it does affect PCB designers quite a lot. So it's a good show for us to be involved with and to be aware of what's going on and what's new in the technology. One of the areas where I feel that our industry needs more closure is that handoff from design and engineering intent to production. I think there's a lot of good DFM tools out there, and most PCB fabs have an engineering process that really does help the designers understand what they need to change, where they need to tweak things. But I feel like there's a lot more we could do with PCB fabricators, for example, to make direct links with the software is one way. One thing that we could do, or that they could do, make it so that designers could have tools for redlining from the manufacturer directly back to the designer, and collaboration together on that handoff process. And so I think in the future that's one area where we need to invest more as an industry in the tools for collaboration and managing data. And the other area is that the supply chain. We've got a pretty good hold on the fabrication of boards, and we have a pretty good hold on assembly. But one thing that engineers and designers constantly struggle with is what you're designing into your product early on, when it's in that early engineering phase, when someone's doing the actual electronics and schematics. What you're designing in then may not be available when the board's all laid out, because that could take, depends on the complexity of the product, it could take half a year for a design to be finished. So by the time you're ready to generate a bill of materials, there's an additional step in scrubbing that bill of materials that requires a lot of research and time, getting into the supply chain and figuring out what can we do, and making sure if there's anything that is no longer available, is there a suitable drop-in substitute that will work correctly under the same conditions. And I think what's encouraging to me is a lot more of the board houses that we talk to are offering more and more full turnkey solutions, where they'll do not just fabrication but full assembly, and they even often have their own stock of parts that are the popcorn components, decoupling caps, resistors, etc., which makes it easier for the customers to know, have that service where they know those things are going to become available. But what we've been doing lately is making sure we can provide the tools to allow people to get an accurate bill of materials right at the time when they're ready to go to prototype and then production. And that's where some of our other products like Siva and Octopart come in, for allowing people to search for and scrub the BOM and go to production. And it helps a lot. But I think board fabs who are turning to full contract assembly can also help a lot with that and take a lot of that burden away from the user. I said before, one of the big problems is this gap, this handoff from design to manufacture, and really part of that comes about because people are still using old standards like Gerber. Gerber is reliable, so if there's this saying, if it ain't broke, don't fix it. And this is important when you're investing a lot of time and money into a design. You want to make sure it works, you want to get to market. At the same time, there's not so much, Gerber format, for example, is basically just image, and now Gerber X2 is definitely a big advancement on that with layer stack information and drills, but it still doesn't cover the entire assembly. ODB++ was a good attempt to cover everything, but what we've seen is market adoption is less than Probably less than 20% of people will use that as a file format. We were very hopeful, and still are, that IPC 2581 is really going to become the new standard that everybody turns to. We definitely see a need for it in the market, for gathering more design information and intelligence into that handoff. So it's not just the images, it's not just the drills, it's complex layer stack information. That's especially important as people miniaturize and there's more and more rigid flex and mixed technology designs like that. A lot of our customers are designing with rigid flex to get things like this to fit these days. There's a lot of medical and military applications, wearables that require it. So IPC 2581 looks very promising for supporting the full detail, so that the manufacturer can take that data set and go straight to production and not be missing any information, not have to go back. We'll still do this for a while anyway, just to be sure, but technically with a standard like 2581, in theory, you shouldn't need to go back and have this big long feedback loop where the manufacturer has to keep asking questions of the designer about what they really meant when they did something here, or what this note means. 2581 contains enough data that in theory you can just go to production, and that's what's exciting about it. We're not quite there yet in terms of adoption. These things, people have to use them a few times before they get comfortable and realize, yes, this is reliable, and all the bugs in the standard or things that scenarios that haven't been covered come to the surface, so we can add those to the standard and then move on. But Altium is definitely supporting IPC 2581. Altium Designer, our flagship tool, will allow you to generate outputs to 2581. And the other thing that I love about 2581 is it gives you very important information about the design. It gives you the net list and the bill of materials, essentially, or the parts list, let's call it. It's not a bill of materials really until you're ready to press the button to order the components, but basically it gives you enough information to do the fabrication, the assembly, and the test. And that's what's really needed, to have everything in that one format. We did see a need in the market that, like, for most of our company's history, we've had a really solid offering for the professional electrical engineer / PCB design specialist in Altium Designer, but we never had something for people who are on a tight budget or no budget, who maybe casually design boards as a hobby, or who are students. And then there's the open source hardware community as well. So people who have a great idea, but they're willing to share with others and collaborate. The thing that's really exciting about open source hardware is the collaborative nature of it. People have an idea and start something, and then others want to contribute and add to it and make it even better. And before you know it, like we've seen this with the software world, but it's happening now in hardware as well, we get better products because people are working together around the world. And we didn't have something until basically 2 years ago. And so what we did was we took the same native 3D PCB engine of CircuitMaker, of Altium Designer, and the same schematic engine of Altium Designer, and we created a free tool called CircuitMaker, which is very much collaborative. It's focused on the collaboration and the collaborative nature of open source hardware design. It's completely free to use. There's no licensing. I mean, there's a license you agree to. It's our code, but basically, if you're willing to do open source hardware design, then you can use CircuitMaker for free. And what differentiates it, what's different about it compared to, say, Altium Designer, is that it uses a centralized, community-based online library, which is linked to the electronic component search engine Octopart. So all of the information about the parts comes from Octopart, and the 3D, the PCB footprints, and the schematic symbols come from our online library that every CircuitMaker instance is connected to. So if I need to use a component in my design and I search for it in the library panel, I can create that component link to the parameters from Octopart, the datasheet, etc. And then once I've created that, it's available to everybody else in the CircuitMaker community. So there's hundreds of thousands of parts in there already, and lots of people able to reuse that information in their designs. A bit like a Wikipedia of components, if you will. It's kind of an exciting concept. And yes, there's, just like Wikipedia, anybody can go in there for free, sign up, and create component models. And yeah, they could break them if they wanted to, and that's okay, because we know with anything like this, people need to break things in order to learn, but also it's a whole community, and a lot of the people there are very experienced and will come and fix things too. Just like with Wikipedia. You know, a lot of people were very skeptical about Wikipedia when it was new, but now you're actually allowed in most universities to cite Wikipedia articles as reliable sources of information. So it's come a long way, and we think the same thing can happen with design content. So that's what CircuitMaker is really about. And something else that sets it apart right now is also the fact that people can join a team and design the same schematics and board together at the same time, and they could be in different parts of the world. So it's kind of cool. It's very exciting to see what's going on, and there's some nice designs in there already. Almost all of them are geared towards the hacker community, people doing robotics, people doing garage electronics, and it's just really cool, and it's got this earthy feel to it that I love. What we're really showing here at DesignCon this year, we've done an update to our PDN analyzer tool, which makes it very easy for professionals, particularly even board layout professionals who may not even be engineers, but who need to get an understanding of current flow across the board, and if they've got a voltage drop problem on planes, they can use our PDN analyzer tool, and you can simulate the board, and it'll tell you if you've got a voltage drop problem or if you have excessive current density in a neck down part of the plane. So, and that can be a good indicator for other problems, thermal problems, and even potential issues with even AC signal integrity, where you might have a ground bounce or something like that because you've narrowed down a power supply path. And we have our data management tool, Vault 3, which makes it easy for people to manage their design content and reuse design blocks, and capture their own component libraries and manage them in a way that means you'll never be missing a footprint. You'll never release a design to manufacture and then realize it was the wrong version of the Gerbers because someone had to make a change. It does all of that proper data management and lifecycle management of your designs and the outputs of those designs, but without having to change your workflow. One thing I do really like about Sierra is they are one of the few board houses that really wants to work very closely with an ECAD vendor like us. Sierra has done a lot to educate us as a design software company on what it is that manufacturers actually really need to get a good data set and to understand what the customer intended. And that's very helpful, incredibly helpful. If you want to know that something's manufacturable and going to be reliable, you can go on their website, and they've got a beautiful layer stack planner and HDI planner, and they're really one of the only companies that can do quick turn HDI that actually is able to do what they say they can do.